Okay, so in this video, we're kind of going to revisit some things we took a look at in 3.2 from the opposite point of view. In 3.2, we had a bunch of statements, if-then statements. If lines parallel, then we showed a bunch of different angle pair relationships like corresponding angles congruent, alternate interior angles congruent, etc. So the converse question would be, well, what would it take in order to show that lines are parallel? So swapping the hypothesis and conclusion, how do we make that conclusion that lines are parallel? So it turns out that pretty much all of those statements, if we take their converse, then we get a true statement. That will prove that we have lines parallel. So we had that postulate about corresponding angles. The converse of that is also true. Now, we're not really going to refer to this as postulate 3.4. This is what your book calls this thing. We're going to write it out. If corresponding angles congruent, then lines are parallel. So that'll be our abbreviation. We'll see that in class here. So this is a postulate. We don't really question this. We just take it as true. Some theorems, and these are all converses of theorems that we've seen back in 3.2. If you take a close look, alternate interior angles congruent, alternate exterior congruent, etc. So for all of these things, notice that these are all the conclusions of the theorems in 3.2. Well, now if there are hypotheses, the conclusion is going to be that we have parallel lines. So basically, it's the same kind of thing we've seen in 3.2, just we're looking at the opposite cause-effect relationship. Instead of parallel lines causing angle pair relationships, the angle pair relationships are going to cause lines to be parallel. The only one that's a little bit different is that number 4 there. If two lines in a plane are perpendicular to the same line, then the lines are parallel. This is really something that's a direct result of any one of those previous theorems or postulates, and we'll talk more about that in class. This really just shows that your alternate interior angles are congruent or that your consecutive interior are supplementary. You can kind of pick any one, and number 4 there will be a direct result of any of those. So just as a quick sort of exercise here, let's take a look at, we have multiple lines here, A, B, L, M. We can automatically tell that B and A are not parallel to L or M because they're all intersecting each other, but it seems like A might be parallel to B and L might be parallel to M. Now we have to be really careful not to assume any parallel lines unless they give us those little parallel arrows on those lines, which they have not, or unless they tell us directly, hey, these lines are parallel. So using the theorems or postulate in this section, they might give you some information, like they might say, suppose that angle 2 is congruent to angle 8. Well, 2 and 8, let's see, you want to identify what angle pair they are. They have transversal L, and L is cutting A and B. 2 and 8 would be alternate interior. And so if 2 and 8 were congruent, that would make lines A and B parallel, because if alternate interior congruent, then lines parallel. Another example, let's suppose that they told us that 8 and 13 were supplementary. Well, again, you want to identify the angle pair. 8 and 13, they have transversal B. B is cutting lines L and M. Now, 8 and 13, they're on the same side of B. So this means that they are consecutive interior angles since they're inside of L and M. If consecutive interior are supplementary, that makes lines parallel. Well, in that case, if 8 and 13 were supplementary, that would make line L parallel to line M. So it's just like 3.2. You want to identify which angle pair you're working with, what relationship that angle pair has, and depending on what angle pair and what relationship they have, that'll tell you, again, the transversal and which line's being cut. That would make certain lines parallel versus others. So that should give you enough to answer the questions in Schoology over 3.5. Again, it's not a whole lot. It's kind of looking at 3.2 from the opposite point of view. And then in class, we'll look at a couple of proofs and some algebra relating to all of this.